Minasan, konnichiwa, Zamurai Engineer. In this video, module number 3 of chapter 5, we will analyze and use cost behavior. Our learning goal is to analyze and mix cost using the high-low method. What is the high-low method? Assume the following hours of maintenance work and the total maintenance cost for 6 months. So we have the following data. So January, February up to June. This is 6 months. We have number of hours of maintenance and the total maintenance cost for each of these months. How to proceed with high-low method? So let us take note of the high and the low data. The lowest here is 500 hours and the highest is 800 hours. So high level 800, low level 500 hours. And each of these corresponds to a total maintenance cost, which is also supposedly high and low. So the variable cost per hour of maintenance is equal to the change in cost divided by the change in hours. Okay? The change in cost is highest cost minus low cost divided by high number of hours minus low number of hours. Okay? So change, that means change. Therefore, if we say 800 is the high and low is 500, the change is 300. Okay, so 800 minus 500 is 300. That is the change. What about for the cost? 9,800 is for the highest and 7,400 for the low. So if you subtract, the change is 2,400. And therefore, we can divide 2,400 divided by 300. And that is $8 per hour. Okay, so this is the high-low method. Total fixed cost is equal total cost minus total variable cost. Total fixed cost is equal to, what is the total cost? 9,800, okay, minus total variable cost, that is $8 per hour times 800. Okay, so it would lead us to what? 9,800 minus 6,400, and therefore the result would be 3,400. So that is our total fixed cost. That is how we solve for the fixed cost component. That value would lead us to the y-intercept, to the y-intercept. Okay, so we have y-intercept right now. And 3,400 as a y-intercept, we can substitute to the equation, which is y is equal to a plus bx. B is the slope. The slope is the unit cost, which we already calculated to be $8. That is what? The change in the cost divided by the change in time. Right? Change in cost, change in time. Change meaning 2,400 change in cost and 300 change in time. So divide 2,400 by 300, that is 24 divided by 3, that is $8. That is our slope. So as you can see, we have the equation of a line, equation of a straight line. So let us check our knowledge from the discussion that we have just learned. If we are given sales salaries and commission, that would amount to $10,000 when 80,000 units are sold, and $14,000 when 120 units are sold. Okay, so these are important points. 80,000 units, $10,000. 120,000 units, $14,000. So those are what? Coordinates of points in the diagram. Using the high-low method, what is the variable portion of sales, salaries, and commission? So it's a very simple, because we just have to subtract the amount, which is 14,000 minus 10,000, that is 4,000, and divide by the difference in number of units, that is 120,000, divide by 80,000, that is 40,000. So 4,000 divided by 40,000, that is $0.1 per unit. So that would be the answer. Okay, that would be our answer. And next problem, the same given, but using the same method. What we are required to solve is the fixed portion of the sales and salaries commission. What is a fixed portion? So it is also very straightforward, as we have just explained some slides ago. Okay, how to do it. We are looking at the fixed portion. So you can rewatch our discussion here, fixed portion. Our discussion, fixed portion here. Fixed portion is the 3,400 here. We have another problem. How much is that? That is the fixed portion, 3,400. So how do you solve the 3,400? Very simple. You can gather this data like this. Total fixed cost minus total variable cost. How much is the total variable cost? Oh. That is what? So let us subtract. That is 0.1, and the maximum is 120. So that is 120,000. 120,000 0.1 per unit. So how much that? So here 120 units. How much per unit? $0.1 per unit. So 0.1 times 120. That is $12,000. So let us subtract that from what? 14,000. 14,000 minus $12,000. $14,000 minus $12,000, that is $2,000. Okay, so let us find out. That is the answer, $2,000. So how to do it? There is an explanation on the green area here. That is a detailed explanation. While I am explaining, you can also look at the video and use this format to solve for the fixed portion of the graph. fixed portion is again the y-intercept. The y-intercept. Okay. So we have another method, what we call least squares method, least squares regression method. What we have just learned is what we call high-low method. This one is least squares regression method, a method used to analyze mixed cost if a scatter plot reveals an approximately linear relationship between x and y. If we can observe that the relationship between x and y is almost linear, this method uses all of the data points to estimate the fixed and variable cost components of a mixed cost. It is more rigorous mathematically, but I think this would give us slightly better output. The goal of this method is to fit a straight line to the data that minimizes the sum of squared errors. We want to minimize the errors. Okay, we can do this. Squared errors because to eliminate the effect of positive and negative. If we square the negative, it will become positive. So because of that, the upper and lower data points will not affect the final representation of the data points. Okay, the method is unaffected by the fact that there are several scattered points above the line and several scattered points below the line. The condition here is that the method will create a representation of line with minimum error. Okay. Okay, so with minimum error, even though there are positive and negative position of scattered points with respect to the line itself. So that is the idea here. So least squares regression method software can be used to fit a regression line through the data points because, as I have said, this is more rigorous in terms of mathematics. Right? It is not hard but tedious. Okay? The cost analysis objective is the same straight line that we are going to find out what is the value of A and B. The output from the regression analysis can be used to create an equation that enables you to estimate total cost at any activity level. So comparing the results from the three methods, we have what? The three methods just discussed proves slightly different estimates of the fixed and variable cost components of the mixed cost. This is to be expected because each method uses different amounts of the data points to provide estimates. Least squares regression provide the most accurate, meaning the answer, the estimate is near to the true value. It is not equal, but it is nearest to the true value. It is the most accurate among the different methods we discussed. It uses all of the data points. So that is our last slide for the module, and we would expect that to see you on the next video. Thank you for listening. Again, this is Dr. DrEYPEI, Teaching Engineering for Nation Building.